and I'm taking population again from fresh or from the start. Now, we started from the definition. The definition, all right? Is there any other marker? So we started from the definition and we said population can be defined. Population can be defined as the total number of people residing in a particular geographical area. All right? Now, I made mention earlier, I said, anytime we are explaining or defining population, geographical is a key word. All right? Good. Then we move on to another aspect of population we call the population size. The population size. Now, under the population size, we have three aspects of population size. We have the overpopulation, we have the underpopulation, and we have the optimum population. Now, let's have a graphical illustration so that we can understand it better. Okay? Now, I'm going to be dividing this thing we have here into two. I hope it suffices. Okay? Okay. So we have something like this. Now, this part of the curve, we call it under. And this part of the curve is called over. All right? Now, in the x-axis, we call it population. And in the y-axis, we call it output per head. Output per head. So, in a scenario where you have underpopulation, it means this is the population we have here. Now, this line has already divided the population size. So, if here is 0, let's assume 5, 10, 15, 20, 25, right? 30, 35, 40. Now, what we are looking at here is, if you observe the scenario here, if you combine or if you compare the two of them, you observe that the population here is low compared to the population here. So that means this is under and this is what? Over. Good. Now, so it means one thing about underpopulation is that the output per head is increasing. You can see the curve is increasing, right? So that means as the population is increasing, the output per head is what? Is increasing. But when you move to over, as the population is increasing more and more, what is happening to the output per head? It is what? It is falling. Have you seen it now? Then the best part of under. Now, if you look at this aspect, you observe that this line has divided the curve into two parts. So it means that the best part of under and the best part of over, you know, it has been shared. So optimum is the one carrying the best part. Are you okay now? Optimum is carrying the best part of under and the best part of what? Over. Okay? Good. So what you call in between, this is exactly what you call in between. So I will come here, the apex region here, I will call it what? Optimum. Optimum population. Okay? Now, so let us give the definition. So for overpopulation, we are going to say overpopulation. We are going to define it as this is a population size. This is a population size in which if you were in class before, what you wrote and this might just be different in words, but it's still the same meaning. All right. So don't worry. In which, so if you look at this, over, where is over? Okay, in which we have what? Higher population size, or you can just say higher population. Higher population are what? And lower or decreasing output per head. Okay, so that's what the graph is showing. So that is, or we can just say, in this scenario, the amount of resources are fewer or are few compared to the population. Okay, so look at this. So in this scenario, the amount of resources available or amount of resources are few compared to what? To the population. So that means population is higher than resources. So we move on to underpopulation. Underpopulation. So just this thing. This is the population size in which, so let's go back to the graph, okay? So there isn't much, thing to cram here, all right? So this is a population size in which, oh yeah, what's the graph telling us? You have what? Now in this case, the population here, we won't say higher, okay? Because this is underpopulation. So this is a population size in which an increasing output per head, is generated as population increases. Okay, so you can see that's what the graph is saying. So as the population is increasing from 5 to 10, what is happening? There is an increase in what? In output per head. But there's something the graph is not telling us. Did the graph told us that the amount of resources are fewer here? No. So the hidden thing that the graph is not revealing, let's now add it. So we come here, we say, in this scenario, so let's continue from here. In this scenario, the amount of resources are greater compared to the population. So what this is trying to tell us is that resources is more than people. Now let's move on to optimum. Optimum population, okay? So like I said, optimum is taking the best part of under and over. So here, what do we say? We say this, you can see. So this is a population size in which there is a maximum output per head Are we okay now? There is a maximum output per head. So let's do justice to how we are going to put it in population. Abi? So there is a maximum output per head in relation to the amount, to the number of population. Because number is for resources, then amount is for resources, and then number is to people. So to the number of population. Okay? So that is what the graph is telling us. You can see. You observe that at optimum, the amount of population is what? Is defined, 25 million. And you have what? A maximum. You observe. What? If I should draw this graph up to this stage, so it means, see where my output per head is. So it means it's a maximum level. So that means we said there is a maximum output per head in relation to the number of what? Population, which is the 25 million. Now, the thing the graph is not telling us is this. In this scenario, the amount of resources equals the number of people. Abi? So the amount of resources equals the population, or the amount of people equals the people. Okay? So that's just what this population size is talking about. So now let's move on to determination of population. Or we can just say factors that influence population. Okay? Factors that influence population. 1, birth rate. 2, death rate. 3, migration. Now, these are not all, okay? But I told you, these are the key determination factors. Because you can have other factors like marriage, religious practices, and so on and so forth. Even level of education. Are we okay now? There are many things that can determine the number of population. But the best part, the 3 key components or the 3 key factors that influences population: birth rate, death rate, and migration. Now, what is birth rate? Birth rate is just the amount of what? Birth in the population. What is death rate? Amount of what? Death. What is migration? It is the rate at which people move in and out of a particular geographical area. Now, don't forget, migration is classified into 2. We have the immigration, and we have the what? Emigration. All right? Now, what is IMI? From the word IMI, you know, when we said imminent, inherent, all these things are coming from what? From within. So when I say immigration, it means you are moving to where? You are moving into. When I say emigration, you are moving what? Outside from. Abi? So when I say, for example, this is a country, YSP. YSP is a country. Now, when people move into YSP, we call it what? We call them what? Immigrant. That's immigration. Then when people move outside of YSP, we call it what? Emigration. That means they are what? Emigrant. Are we okay now? Good. Then from here, these are just the factors that determines what? Population. Then death rate can also be called something. We call it mortality rate. We call it mortality rate. All right? So this is the idea, all right, of the factors that determines population. Okay, these are the 3 important factors to mention, because there are others, like I said, religious practices, marriage practices, cultural practices as well, okay? But I just want to give you those things that are very, very what? Important. All right? Good. Now, so let's move on to population distribution. Population distribution. Now, I'm sure you'll be wondering, do we distribute the population? Yes, we do. Population distribution. Now, we have three distributions. Three important distribution. One, the sex distribution. Two, the age distribution. Then three, we have what we call occupational distribution. Let me write it clearly. So let me repeat myself. One, sex distribution. Two, age distribution. Three, occupational distribution. Now, we are not going to stop there. Now, let us see the subdivisions. So if you look at sex distribution, okay, that means we are trying to distribute the population into some component parts. So what are the component parts of the sex distribution? Very simple. Is what? Male and female. So let me clean this section as well. All right, so let's do this. So for the sex, I will come here. I will say male. Then for the next part, I will say what? Female. Okay? So these are the key factors there. Male and female. Then let's move on to age. For age distribution, we have three important components for the age distribution. Now, for the age number one, we have what you call 0 to 17 years. Then we have 18 to 60 years. Then we have above 60 years. Now, listen to this. 0 to 17, we can also call it something. We can call it dependent population. Dependent population. Hope you are with me. Now, look at this. From 0 to 17, what do we call them? Dependent. Now, 18 to 60, we call it independent. Independent population. We can also call it something else. We can call it working population. So the PD stands for population. Then you can have the third one we call labor force. You know, these are the amount of people that are willing to work, or the amount of people that are available to work. So then above 60, we can also call them dependent population. We can also call them aging population. You can also call them static population. All right? Now, don't worry, I'm going to explain this one, okay? Let me go to the occupational distribution. Or let's explain, let's do justice to one of them as we move along the line, okay? All right. Now, 0 to 17, what do we call them? Dependent. It means these are people that they are not eligible to work. All right? That means they are depending on a particular guardian, okay, to feed them and to give them what? Their basic necessities of life. Then you move on to 18 to 60 years. These are people in the working class or the working population. That means we can call them what? Independent. They have the right, they are legitimately what? Accepted to work. Anything above 18 years. So you can also call them what? Working population. You can also call them labor force. Because these are the people that are available to work. They are available to work or to engage in occupational what? Activity. Then above 60, we call them dependent because we see anything above 60 as, a retirement age. This was the thing that led to setting a retirement age at 60. All right? So retirement age 60, you are not meant to work. Though I know you have a question like, what are those people that are over 60 years that they are working? What do we call them? Fine, they are working. But the main standard theoretically is that anything above 60 years, you are static. Are we okay now? Meaning that your productiveness cannot amount to anything in the economy. Are we okay? Now, the best part is these people here. Now, you can be a CEO. Over 60, you can be a CEO. You can be, you can take part in something, but more like a supervisory role or an authoritative role, just giving orders. Are we okay now? But the thing is that the reason why, or the reason we say these people are the labor force is that, they are actively engaged. Are we okay now? They are what? Actively what? Engaged. Unlike what? These guys here. All right? So theoretically, now, I made mention of something, I think maybe in this, the second or third week of this class. I said most of the time, economical principles or economical theories, they can work, they are in two ways. They can be theoretical. They can be theoretical, or practical. Now, listen to this. Theoretically, it works. Practically, it's 80-20%. Are we okay now? Now, most of the time, I'm telling you this because most of the time, so that when you are reading, you can be what? Guided. Now, sometimes when you read something, theoretically, it fits into the description. But when you try to apply it practically, sometimes it does not fit in. We just finished or we just concluded market structure. Are we okay now? We learned something about perfect market, right? And in the perfect market, I explained something. I say that market practically does not exist. Are we getting it? So it means that when we look at some things in economics, practically it doesn't fit in. But theoretically, it does fit in. Now, that's why most of the time, when we are reading economics or when economists are trying to give their assumptions, what did they say? Most of the time, they make assumptions. Look at it here. They make what? Assumptions. And their main assumption is what? Ceteris paribus. Is that not it? And what is ceteris paribus? All other things being equal. Okay? Now, so these are the assumptions. Now, the reason for this, I'll tell you the reason. The reason for this is that just like sciences, sciences, they make hypotheses, right? They make testing, they make experiments. Now, in economics too, we also make testings and experiments. Are we okay now? So when we make our testing, all right, and we see that it has worked out, okay, then we can now apply it what? Practically. Okay, so most of the time, before a policy, or let's just say, before a theory can be called a theory, Abi, it must be what? It must pass through experimentation, or it must pass through what? What do you call it? Hypothesis testing. Are we okay now? So when that theory, it's an hypothesis, right? When it has passed that stage and it is accepted and it is what? Tested, it is working, it's fitting practically, then we can call it what? Theory. But there are some concepts, when you try to fit in practically, it's more like 50-50. Okay? So just take note of that. Good. So we can see now. Let's reason into this. 60 years, they work, right? Though they might not be actively engaged, but they are working. Are we okay now? Good. So that's why we classify them here, because probably they feel they are not actively engaged. So we call them aging population, which is certain, old. Then we call them what? Static population. All right. Now, let's go into something. Let's go into our occupational distribution. Now, for occupational distribution,